Hey everybody, happy Sunday morning. It is Sunday the May 20th. We're still got our May grays going outside, but what am I here for today? I'm here to do a little bit more detailed video on one of my Internet of Aquaponics projects. I posted in an Aquaponics group and a lot of people are interested, so I'm going to do a more detailed video on one of the simpler ones. The one I just finished here. If you saw my app before, it's right over here. This sensor, finger, right here, is going to be measuring the water level of my top-off tanks. I have currently 3 IBCs connected together, which when we ever get rain, in San Diego we don't get much, it will fill up from rain. Otherwise, what I do is I shut off one tank, fill it up with water from the hose. I have an air stone in there, so it will dechlorinate. I let it go for like 3 or 4 days. Open up the valve so it all levels out between the 3 tanks. And then I will do that a couple times until the tanks are at a good level, and then forget about it for a while, and hopefully a long while. This is the first year using the system, so I don't know how long it will last when full. And if it wasn't for a few of my errors, stepping on pipe or leaving a valve open, something, I would have had a lot of rainwater to test this with too, because last storm we had did fill up all 3 tanks, which is about 750 plus gallons. And I hope to expand that to 3 more tanks. I have a total of 6 over there. So with a good winter, I hope we'll have enough water there for all summer. And I have videos in my playlist down there in the Aquaponics playlist, I think, on those tanks. And I'll show you the tanks when we go out there to install this module later. But right now, let's show you the module. This is the kit box I bought from Fry's. And the main part of it, again, is, get some light over here if I can, is what they call a node, my finger, can't get the right way. It's called a node MCU. Now, a lot of people are familiar with Arduinos, Pi, or Raspberry Pis. And you can do this with those, but those are kind of overkill. For one, the Raspberry Pi is basically a computer. It's a little mini computer, and you can do a lot of things with it. And they're about 20 bucks each, I want to say. So to me, it's kind of overkill. Arduinos are cheaper. You can get an Arduino for $10 to $15, I want to say. They don't have Wi-Fi built in, so you have to buy a Wi-Fi module or one of these to plug it in to the Arduino, and then you get your Wi-Fi. These things are microprocessors and can do a lot of what an Arduino can do. And it has a built-in Wi-Fi, and you can get these things for $8 or less. So I think it's a bargain. And you can, like I said, if you saw the video on my temperature water monitor, I have 4 sensors and an LCD screen attached to that. And with the what they call like one wire format, I can put a number of sensors that read the one wire format. And then it has a bus. The LCD is connected to a bus, 2-wire bus. I can put a lot of bus. It's called I2C. I can put a lot of devices on there. So this little module can do a lot, almost as much, if not more, than what the Arduino can do. And it's cheaper. It's smaller. Arduino would not fit in this case. So that's why I like it. Now this is real simple. You can see there's not much to this. This is probably the second simplest one I have besides the sump pump, which is about to get more complicated because I'm going to put water flow on that as well to monitor, make sure my pump is flowing. So give me an alarm if it's not. So this is only attached there for programming and right now for power. What I did is I attached a 2-pin terminal strip. So I'm going to run power from my power box out to my tanks, and I'll wire it in there. And then I have that wire, and I'm not going to show you my shoddy soldering job. It's not very pretty. But I have the wires, these wires here, come over to the red positives going to VCC on the node MCU. That's where you would put input power to this if you're not using USB. It has a built-in voltage regulator, so you can put 5 to 10 volts to it, and it regulates it to 3.3 volts for the system. And then you'll have lots of, well, not lots, there's 3, and I'll show you the pinout here in a second when I do a screen share. It'll give you 3.3 volt outputs and grounds. So, like on the temperature sensor, it can use the 3.3 volts. The LCD and the pH want 5 volts, so I have them. And same thing with this. This is an ultrasonic sensor. Let me grab one out of the box. Where did I put the box? And all this stuff I got on Amazon. Well, most of it. Some of it I got at Fry's. This box of 4 ultrasonic sensors was, I want to say, around approximately 10 bucks. It's not expensive. The only thing I have, and somebody pointed this out on a thread, concern about is this is going to be sitting on top of my water tank, and I'll have a hole drill cut out on top of the IBC. It will most likely condensate at times, especially with dew just in the air. I don't know how well this is going to hold up long term. I don't think it's stainless steel. But we're going to see. They're cheap. And I have it set up so I can just plug it in and set a new one in there. And silicone the edges. They do make and it's basically it's 2 of these built into one device. And it's supposed to be industrial strength and waterproof. And it kind of snaps into a hole. And it has a lead wire to it. And it's about $15 for one of those. So if this does not hold up long, then I'll just modify this and put one of those in. So let's get back to this over here. So the ultrasonic sensor only has 4 wires you need. Power, which is the VCC input. And then the pin over here on the other side is ground, which is your negative. Then it has an echo and a trigger. So all it's really doing is it's putting out sound waves. They bounce back off the water, hopefully. And people have done this before, so I'm pretty sure it does. And then it hits this and triggers. And so it's sending pulses to your node module here. And you see here, I got my red and black wires. And I'm just using jumpers that you can buy, again, from Amazon. I'll show you those. You can buy them with a socket side, a female on both sides, a male on one side and a female on the other. If you're doing a lot of breadboards, which I've been doing, I got the ones that have males on both sides. But in this case, I used male on one side, female on the other. Just put the female side over the pin on the ultrasonic module, and then I took the male side and I just soldered it there with my power terminals. So it's going to get 5 volts as well. I have a 5 volt, 12 amp power supply on its way. And it was only 13 bucks. I was looking for 5 amp, 3 amp, but the 12 amp was only a couple bucks more. So, I plan to put a lot more of these modules out there to control valves, to control water, air, all sorts of stuff. I want this thing automated so I can see everything that's happening on my phone, and I can push buttons and make things happen. Like, I often forget I turn the air off to feed the fish so I can see them and all the food isn't blown to one corner. Sometimes I forget to turn the air back on. So I want to put those on valves. And so I can look at my phone and see, oh, I forgot to turn the valves on. Just click the button on my phone. So those are the things I'm working at. But back to this. I digress. So we're taking, let me see which is which. The trigger wire is on yellow. So I have that going to pin D4. And the orange, the echo, is going to pin D3. And again, I just soldered those into the boards there. And I did put what they call headers. I bought a long These I got at Fry's, but you can get these at Amazon too. I got a long header pin because I didn't want to solder directly to the Node MCU because heat, I'm leaving the heat on there for too long and it could cause damage. So the Node MCU uses 15 pins, 2 rows of 15 pins. You just snip this, you lose a pin, no big deal. And so you can see there, I put 2 there so I can plug in the Node MCU. And then if anything ever happens to this one, I can pull it out, put a new one in, flash the program to it, and I'm done. It's running again. Let's make sure it's still running. Yeah, it's on red because I have it down, but I turn it up on its side, and hopefully, unless my pins came loose, which they could have. Oh, there it goes. I just kind of put my fingers on the sensors. So that's it for the wiring of it. It's really simple. And if you don't like doing any soldering at all, you buy these breadboards, and they're only a couple bucks. For this project, I do something like this because the Node, I got some of these to use, but this will hold one Node MCU with only 1 row on the sides to be able to put your jumper pins. And I wanted to combine, I'm combining the power there, the 5 volts. So that's why I put it on the solder board to put enough room for the terminal and the extra 5 volt wires. But if you have room, yeah, this wouldn't have fit. But if you buy a box big enough, all you do is get one of these boards, plug in your chip there. Here's the little terminals. I got these at, again, Amazon. It was a couple bucks or a few bucks for a whole bag of these things. And, oops, let me just do it the other way. I just push it in there. It's not staying there. There you go. So there's a terminal strip. I put my Node there. And I take my male-to-male jumpers. I'll do a female one here. You just take your jumper wires and you plug it in. Everything on this board across, except for the power strip, all these holes are soldered together. So I put this wire right there and that hole next to that. So this is the same thing as that terminal. And then if I had a male here, I just plug that in next to my Node MCU VCC, and that's power. And then you gotta have a big enough box to tuck these wires in there. But you do it that way, no soldering at all. So again, it's pretty simple. So what I'm going to do now is I'm going to go into screen share mode, and I'm going to show you the code I used to make this work. So don't go away. All right, here we are. I'm down here in the lower right corner. Thought I'd start off real quick. Like I said, I was going to show you the Node MCU and the pinout. You just Google Node MCU pinout and you can find this. I mean, you can see there's lots of them out here, but here's all the pins. These are all pins that you use for all types of sensor input. On my Tempa sensor one, I'm using pin D1, D2 as a bus for my LCD. I'm using this this is analog input is for my pH. And then I use all these other ones for temperature sensors or whatever. In this case, for this ultrasonic, we're using pins D3 and D4 for the input and output of for the data. And you can see if you need 3 volt power, you got 3 volt there, grounds. Right here is your input power. If you're not going to use the USB for power, this is where you would input, preferably 5 volts, but if you have a good 3.7 volt battery, you can put that there as well, like I try to do with my sump alarm. But there is that. So let's jump into the programming. This here is Arduino IDE. It is free open source programming software for Mac and you others. I'm a Mac, I gotta admit. It you just Google Arduino website. I'm not sure what the website is for Arduino, but you download this, and it also works for Raspberry Pis, the Node MCU. You just gotta and I'm not going to get into that now. You can Google how to do that, but you basically got to tell it what device you're working with. I think you do that in preferences. But you bring up your Arduino. This is the you'll be basically putting this URL in here so it can grab what it needs for the Node MCU, which is basically an ESP8266 with peripheral devices. You can get a bare bone 8266 board. It's basically a Wi-Fi, but it doesn't come with a voltage regulator. It doesn't come with the serial adapter you need to program it. So the Node MCU is basically an 8266 with all the peripherals that make it work nice and neat development board. So, and there's a couple other things you want to do. You want to make sure you install libraries for sensors you need, and I'll go through that here. Again, I'm not a programmer. This uses some C language. I don't know it. I don't profess to be an expert in it at all. I'm what you call a copy and paster. I find a code, and there's a lot of codes out there, what they call sketches. This is basically called a sketch. And I copy and paste what parts I need, and I know enough to figure it out to make it work. I do a lot of programming on websites with WordPress, so I know how to figure out code and make it work, but I don't know code. I couldn't sit here and type out the code. But we can go through here and I'll show you what everything is. Blink here, well, the first one include is it's going to grab out of your libraries and to load up is the 8266 Wi-Fi library. So it's grabbing that and going to load it up so Wi-Fi will work. And Blink here, Blink is the app, and their website is blink.cc. They are the app. So you don't need the app to make this work. You can have this run off just LCD if you want. But the app is nice because it goes to your phone. And so there's two parts here. There's the Blink stuff, and then there's the other stuff that just makes it work. That's what that is. And the Blink timer is, again, it's a timer function because I'm having it go out and get information every so many seconds rather than continuously run and wear down the battery. Or Blink doesn't like, you accessing their server every millisecond because it's free, again, open source. So you want to play by their rules. Blink auth token, authorization token. When you develop a project on Blink, and I may do a video on that another time, it will send you an email with an auth token, and that goes to this particular Node MCU. So, and with Blink, you're not gonna be able to see it down here. Like on my app, I have multiple Node MCUs tied to my one project app. So, but I would get a authorization code token for each Node MCU, and you would plug that. It's a long string. You can just copy that in here. The next part is your Wi-Fi credentials. I have a Wi-Fi network here in my house. You're going to put in the username and password there. I have mine X'd out now. So, and I recorded this video a little while ago, and I left it in there, and I figured it out, and I go, oh crap. So I did the video over without showing you guys my network. But, and again, define variables. You need to, like in programming, you need to define all the variables you're going to use. Excuse me. And that stuff, I don't really know off the top of my head, but when I copy and paste, I left the stuff in there so it works. And the next section here is a setup section. When your Node MCU boots up for the first time, these are things it's going to run only once at boot up. And so I basically have it here, the trigger pin and echo pin, it's assigning the pin. Such the trigger pin as the output, such the echo pin as the input. And then it's beginning the serial port, and it's blink begin, meaning it's starting up the blink and your Wi-Fi and everything. And then it's going to go run another section of my code down here every second. They don't have seconds. Everything's in milliseconds. So 1,000. is a second. And that's a long time in computer speak. So, and then you end brackets. That does that. Damn. Now the loop here is something that happens constantly. It's going to keep on replaying it. Blink doesn't like you having a lot of blink commands in here in the loop. So I try to take things out of the loop here, even stuff that could possibly go in there. I put it down here in my section here of getting my sensor data. But what it's doing, it's, I don't know what that's doing. Trigger pin low. It's setting the trigger pin to low after it goes high, I guess, after every time. And it's the delaying in microseconds, 2 microseconds. It will go back after that. Then it's going to run my timer up here. And then it's going to run blink. Blink likes only these 2 items in the loop. And I don't know if I could move those things out. Maybe I'll try it. But like I said, I got this from copy and pasting, and it works now. So I'm happy. And then this is the section that's being called for up here every second to do its operations. And yeah, so right here, it's the trigger pin set to high. That's sending out its trigger, and I guess it's sending out the pulse. And then right into L. So I probably don't need that in the loop. I might experiment before I put this out there and take it out, see what it does. And then this section here reads the echo pin. And you see these, when you put the 2 slashes, like most code, it's a comment line telling me or you what this next section does. And I kind of got that from copy and pasting. And if you find a good sketch or codes out there with good comments, so you could know what each section does and play with it. So this is reading the echo pin, returns the sound wave travel time in microseconds. That's the duration. Which I think way up here. We define the variable duration, and long is long string, and distance is an integer. So it does all that. And then down here, it's calculating the distance. Again, what it did first is the code I got just had this duration times 0.034. Most of the codes you see out there, because of these modules or whatever, are done in metrics. So the initial code I got was returning centimeters. So I added this divided by 2, I think. Maybe divided by 2. No, the divided by 2 was in there because it was measuring both the distance out and the distance back. So divided by 2, it's giving you 1 distance. And then I multiplied, this is in centimeters, so I multiplied it by this number here to give me inches. I'm here in the US, so if you want centimeters, you would leave off this part right here. And then what this does here is it prints out the distance on the serial port. Click this button up here, and you can see that. Oh, I have it laying flat, so it's giving me a weird number. So I'm going to prop this up, and there it goes, 3 inches. So having a little issues. But you can check the serial port, you check your programming before you start hooking up the blink. I don't know why it's doing those numbers. There we go. Now it's settling down. And it's bouncing off my printer here. So you can check that. You don't need that if you're using the blink module, or you don't need that. So you can comment these lines out by putting the 2 dashes, slashes, or leave it there. Next line is I add this part of the code in, level equals 40 minus distance. So distance is the distance between the sensor and the top of the water. I measured my tank, and it's 40 inches high from the bottom to the top, to where the sensor is going to be. So basically my level is going to be 40 inches minus the distance. And float is a code term. It will give you a decimal point, and you can adjust that. And this is the part for blink. I'm getting it here on my phone. I put blink virtual write to virtual pin 2. The pin doesn't exist in the physical world, But when you're programming your blink, with this little widget down here, it's going to ask you what pin to read. Well, I'm assigning this number to virtual pin V2, and then I'm assigning level to it. So it's going to write level, whatever it is. This was coming back 9 to 10 inches. So level is going to be 30 inches or so. If it works, probably have to check my solder joints. It's bouncing around. And then I put in this part here, and you have to define the colors. I don't think so. But I said if, this is basic code here, if level is greater than 10, and less than 19, I'm setting the virtual pin, the widget on it, color to orange. So it's going to give me a kind of a warning, the water's below good. And you can do that whatever level you want. I might change that to a different, range. That's a range about 9 inches there. If it's greater than 20 inches, so from 20 to 40, I have it set to green. And if the level is less than 10 inches, I set the color to red. And that's it. And then once it's plugged in, I just click this little button here, and it uploads, it compiles the code, and kind of checks it to make sure it's all right. If it does, then it loads it up, and you're done. So I'm not going to go into the blink part about it. Well, I can right now. I'm going to go back to full screen, and I'll show you the blink part real quick. All right, we're back here, and I forgot I had this app here so I can show you my iPad easily. Get comfortable. So, this is the Blink app, and this is my app I've been working on. You can, it doesn't quite fit perfectly on the iPad. It's made for a iPhone. So let me see here. Up there is the sump alarm. Won't go over that today. Here's the water monitoring. And what we're looking at, oops, I keep on trying to scroll the wrong thing. This is the level indicator for the ultrasonic. So I'll show you real quickly. This is the app. This here shows you all the modules attached to this project. As you can see, I have my sump alarm. It's outside online. Rain tanks is what we're working on right now. And the temp's offline right now. Yeah, it's offline. But it tells you that, so if something goes down, you can program it to let you know with an alert, or just you have to check it every once in a while. I have an alert set up for my sump pump. Let me show you that real quick then. Sump alarm. Can I click it? Oh, the whole thing's running, so I can't do that. So you press that little square, and it stops the app from running, and you can see the little dot. It's kind of, you can click and hold and move things around, resize them, whatever you want to do. You click an empty space here, and here's all the modules you can do, or widgets, they're called. Let's go back to display ones. There's the notifications. I'm using this level, vertical level. And what you're seeing here, and of course up here, when you first sign up, and you can actually download the app on your appropriate app store to your device, and you can sign up for an account right through here and start your projects. These are energies, and I said it's free, and it is free to a point. When you open your account, you get 2,000 energies. So you can add as many widgets, add up to 2,000 for free, and use it for as long as you want for free. Now, I kind of bought energy for one to support the project because it's really, really cool. Really, I don't know what the word I'm looking for, but it's well done, and it's useful, and I'm having fun with it. So I bought some. You can just click there and you just buy it. You buy it through your app store as an add-on purchase. Oh, great. So I'll get back to her later. So anyway, we're going to click off of that. And you just click on the widget and you can see the widget settings. Here you can name it. Here you can set the base color. And here's what I told you about the pins. In our programming, we set it's a virtual pin 2. So it can be an analog pin, which I don't know much about. But the virtual pins, you have, I think it's 10. Oh, you have a bunch. Look at all those virtual pins you can use. I don't even know how many you have. But so you can get a lot of information there. Let's go back to virtual pin 2. There we go. And that's it. You hit OK. And then the numbers there is you can set the range that you're measuring, that you're showing there. And I'm going from 0 to 40 inches. And that will, so it's showing the graph from 0 to 40. And take the numbers and it'll show the graph appropriately. Flip axis, you can show it so the graph's upside down. And this actually should be set for 1 second. So every second it's going to get the information from the server. Because the way I have it, when you use a write to pin, it's writing the information down in the server. So you have a database of all the data. And you can do a, and here's a source. I'll get back to that in a second. The source, you will click which, you should probably, that should probably be at the top because you set all that stuff up and you realize you're on the wrong node. And then when you select the correct node, it erases everything. So you have to start over. So make sure you go down and click the node first. We'll click OK there. And I'm going to go to tab 2 here. It's not tied to anything right now. What you see right here is a graph, a history graph. And you can tie it to, and you can have multiple points going across it here. So you can add different data streams. I was monitoring my sump power there, but I can change that. Oops, wrong one. That's just naming it. I can change it to rain tanks and pin. Go to virtual pin 2. And that should be it. And then press play. Start the app. And no. It does work. I have done it before. I'm just probably not doing the settings correctly. But you can actually have a graph there of your temperatures, your pH, and then you can compare the two. See how your pH is going with your temperatures. So there's a lot you can do there. And then you can, if you need to, after a period of time, you can download it. I think as a CV, export as a CSV, and then you can import it into Excel, and then you can erase all your data there too. I don't know if I'm going to do that with this device. I'm going to do it with my temperatures, my pH to monitor. And this one down here is actually monitoring the temperature. Excuse me, I'm about to sneeze. If you saw my last video, I have a temperature and humidity sensor inside the case. So I don't really need this up front. I might just do it as a label. But I can measure the temperature inside the case. This is a labeled value, and this is a gauge. And this is a horizontal graph, and then you can put LEDs that will change colors. You can add buttons. Oops. You can add buttons that will do things. Joystick, vertical sliders, and the button can monitor status as well, like my air valves. I can have the button turn on the air valve, and then if I have another wire monitoring the position of the air valve, this would tell me if the air is on or off. So there's a lot of things you can do with this. But that's basically how we went ahead and got our water level set up. I'm going to press play. When you're all done with everything, press play, and it will, caps. It will be running. And alerts don't have to, you can, like I said, over here in tab 2, I have a notification. Oops, stop, play. That's what I have the notification. It's tied to, I think it's an all or nothing. Notification setting is you can set up in programming to notify, do an alert on your screen. I have one for my sump alarm. So when my sump low water alarm goes off, it sends a notification, a pop-up notification on my device. And it does it with the apps running or not, which is great. And it appears at the top as a high priority. You can set the priority here. It's high or low. High is you have to click on it to erase, or you have to click on it to get rid of it. And low, it will go away by itself after a period of time. And here I can set up, in which I will set up once everything's on there. That will give me a notification if any of these devices go offline. Lose power or something. I can have an ignore feature. Delay 10 seconds. So if it's just a power glitch, I don't want to get a notification if it's a power glitch. It's going to come right back up. So that's the basics of the blink and essentially everything for this ultrasonic alarm. We're going to press play, get back to tab 1. For ultrasonic water level, not alarm. So I went into a lot of detail making this video long. I hope you guys stayed through it. If you have any questions, let me know. I will, I was going to say, maybe I'll go out there and show it hooked up, but we don't need to do that. We'll do that later. So that's going to wrap up this video. It's long enough. You don't need to see any more. You can see how it works. If I go move this back, it's kind of glitching right now, so I'm going to have to play with it. See why it's glitching. It's probably picking up multiple devices in the path. That's what it is. I have a bunch of crap sitting in between it and the printer. So if I move it forward, I'm filling my tank with water. I move it back. That means the water tank's going down. I gotta check my pins. I'm sure that's a pin problem. I think I didn't do a very good solder joint on one of the pins. That negative numbers, that's what's telling me, is my pins are messed up. So I'm gonna go ahead and unplug that, and I'm gonna resolder my pins there. I'm just waiting for my power supply. It's supposed to arrive today from Amazon, then these things are going out. But again, that's it for this video. Long ass video, but it should answer a lot of your questions about this or get you started. And maybe I'll do another video on the temperature and more in-depth stuff as I go. But that's it for today. I hope you guys all have a great week. If you didn't see my Aquaponics T-shirt, this is my own design, and I have links below if you're interested in purchasing one of these. Oh, rain tanks. Oh, I unplugged the rain tank here, and that there it just shows you. It gives you a notification. So anyway, buy my T-shirt if you like my T-shirt. I'd appreciate it. And like, comment, and subscribe. I do videos on aquaponics, gardening, other home projects, reselling, T-shirts, just about everything. It's about my life. So anyway, have a good week, guys. I'll talk to you guys later. Hey guys, bonus section. Power supply came in, ran a wire. I originally was going to put it on that tank, but this is the tank that's closed right now, being dechlorinated. So I put it in this tank so the wire's off a little bit. But I drilled 2 holes in the top, set it down over the 2 holes, and powered it up. And here we go. Showing me I have 17 inches of water left. Someday I'll do the calculation for inches to gallons and put that in the program. But how's this for accuracy? Actually, it's about right there, but 17.5 inches. That's pretty good. It's good enough for me. Let me know when my water's low. So I'm gonna have to I'm gonna put a bead of silicone around the holes. Finish put the screws in. I might put some type of housing over that to keep it a little more watertight. Because it's right now it's under the eave, but it'll still get rain on it. And I think what I'm gonna do is when I drilled the holes, there was water on the top, probably from condensation. Not a lot. there's some dry spots and some wet spots. So what I'm going to do is, that might be because this was sealed. So what I think I'm going to do is I'm going to cut a section of this netting out, and I have some extra ones of these, and make a little lid for it to keep airflow in there. Let's see over here. Yeah, that one's wet too, so it might not make a difference, but I'm going to leave it open for right now, and then put some netting over it. So that's it. Water level is going to work, and I'll probably should have thought of that before I brought it out here. But I probably should put a quick disconnect, because otherwise I have to take it open to disconnect the wire. But I should have put in here that if it gets down really low in the red zone, it sends me an alert. And think about that. You can program these things over the air through Wi-Fi, but you have to add something to the code first. So I'm going to do some research on that. So when I decide to go ahead and disconnect this and bring it in for updated programming, I'll put that bit of code in there, so all future updates I can do over the air. But that's it for this video. I know I said goodbye already, but have a great week, and I'll talk to you guys later.